Electrospinning is a fiber production method that uses a high voltage electric field to draw a charged polymer solution or melt into ultrafine fibers. As the solution is ejected from the nozzle, the electric field overcomes surface tension, stretching the material into continuous nanofibers that deposit onto a collector. Electrospinning allows the production of fibers with extremely high surface area, controllable porosity, and nanoscale diameter. These properties enable enhanced filtration, controlled drug release, improved self-adhesion in biomedical scaffolds, and advanced surface functionalization in energy devices and sensors. A wide range of materials can be electrospun, including natural and synthetic polymers, ceramics, composites, and even biopolymers like collagen or chitosan. Conductive additives, nanoparticles, and functional molecules can also be incorporated to tailor properties for specialist applications. Yes, while traditional electrospinning produces 2D fiber mats, advanced techniques such as controlled collector movement, near-field electrospinning, and layer-by-layer deposition can create 3D architectures. These are especially valuable in tissue engineering and advanced filtration. Electrospun nanofibers are widely used in cosmetic industries, medical scaffolds, wound dressings, drug delivery systems, filtration membranes, energy storage devices, sensors, protective clothing, catalysis, and environmental remediation applications due to their high surface area and tunable porosity. Yes, when functioning with piezoelectric, triboelectric, or conductive materials, nanofibers can convert mechanical motion or pressure into electrical energy. These nanofiber-based energy harvesting devices are used in wearable electronics, sensors, and self-powered medical implants. Absolutely. Nanofibers enhance textiles with properties such as breathability, improved moisture control, antibacterial function, UV protection, filtration, and thermal insulation. They are increasingly used in sportswear, medical fabrics, protective gear, and next-generation smart textiles. An electrospinning system requires a high-voltage power supply, a controlled shrink pump, or solution delivery unit, a spinner nozzle, and grounded collector. Precise control of voltage, flow rate, and environmental conditions is critical for consistent fiber formation. IDASONIC has already engineered complete, ready-to-use electrospinning solutions. You can now visit idasonic.com and explore our Nanofiber series.
For more information, visit our website idasonic.com.